Hi, so this is week 11 tutorial, second video. So we're going to design the shaft based on the maximum shearing stress criteria, but we're going to look at the stresses that is induced due to the normal load. So let's look at normal stress now. Okay, so let's look at normal stress. And we know this is stress X. So due to axial load, the axial load Px, okay, so stress X is equal to minus 2500 divided by pi c squared, where c is the radius of the shaft. Okay, and then due to the bending moment, so we have m in the z direction, so stress X will also be equal to so minus m y over I. So this will get us to be minus 18,000 multiplied by c, which is the radius, then pi over 4, and then we have c to the power 4. So this will become 18,000 times 4, 72,000 divided by pi c cubed. Okay, so our normal stress in the x direction will be equal to minus 25,000, sorry, 2,500 pi c squared, and then minus, because they're in compression mode, divided by pi c cubed. Okay, so I can get the terms together, common denominator, divide by pi c cubed. Okay, then we also next we're going to find due to the torque, which is Tx. So the shear in the xz direction is equal to Tc over J, and then the torque will be equal to, we calculated the torque to be equal to 227,600, excuse me, multiplied by c divided by pi over 2 c to the power 4. Okay, so this will give you 55,200 divided by pi c cubed. So now we have our normal stress and our shearing stress, so we go back up here, right? We know our values over there. We can now sketch, more or less sketch our mold circle. Okay, so we're going to roughly look at our mold circle now. So we're going to go for so this is just a sketch, by the way. Okay, so we know that this is our normal stress. We have our shearing stress, So normal stress, shearing stress, element rotate clockwise, anti-clockwise, and we call this our point X. This will be our point Z. Okay, so we have our shear. So I'm going to draw. So we know that we over here, this is our stress Z line, right? Zero stress, and then we have our, do it somewhere around here. This is our stress X, and then the shear. So I'm going to take our shear somewhere around here. So our X point will have an element rotation clockwise. So clockwise will be on top. So this is our point X. Okay, so this is our point X over here. Right? So if you look at element rotation, put your finger at center, this arrow will generate a clockwise. So clockwise. So this is our anti-clockwise Z. Okay, so that's our Z. Okay, 0, and it's going anti-clockwise, which is correct. So we can more or less sketch our move circle now. Right, and then we will draw our circle. So sorry about this. So this is about our circle. So I think it should be bigger a bit. Sorry, I know I don't want to waste your time. Me messing around with this is ridiculous. Right. So this is one of our circle. And some of you ask me, how do I know that this in plane is my sorry, I'm still messing around with it. I should stop. Okay, I don't want to waste your time. Right, I think I'm happy now. So we know that this is one of our circle, right? So this is then where point Y is, because this is 3D by the way, okay? So where point Y is here, right? Because point Y have 0 normal stress, 0 shearing stress. So this is where your point Y is. Alright, so if you look at Y direction, we got element, our Y direction, there's no stresses at all. Okay, in the Y direction, 0. So this is one of your circle over here. Alright. And the pink circle that I've just drawn, this is for your YZ plane. Then the first one that we've drawn, this is for your XZ plane. And then the last one, the last circle that I'm going to sketch out, 2, 4, 5 a bit. It's this one over here. Right, so this will be our XY plane. So in this context, what we're trying to identify is that the exact plane, at the exact plane, we know that this will be our stress mean, and over here this is our stress max. So why this is important? Because now we know where our stress max and stress mean is, then we have to apply this equation, where the maximum shearing stress is going to be half of stress max minus stress mean. Okay, we cannot use the other otherwise the other formula. So we have to find where is our stress A and stress B, right? So when the principal stress, so we have to apply that condition. We cannot just stick to this condition where stress max is half of the normal, the shearing stress max is just half of the maximum stress. So from here, we know that now. Okay, so we are going to find. So we can declare that the in-plane circle del zx max is equal to del xz max, and this is equal to our tau max. Okay, we know that now. So the first thing we're going to find is we're going to find the center of our circle. Okay, we're going to find center of circle. So center of circle will be stress x minus by normal stress z divided by 2. So this will be equal to minus 2500 C minus by 72,000, and then divide by 2 pi C cube. So that's the center of circle. Next, we're going to find the radius of a circle. Okay, so this will be equal to square root of minus 2500 C minus by 72,000 divided by 2 pi C cube squared plus by 55,200 over pi C cube. Okay, and then the whole thing squared. So now we can find our stress A and stress B. Okay, so we can find our stress A and stress B. So it will be equal to this term over here. Okay, and then plus or minus the radius of the circle. So what we are trying to do now is, so we have to meet the condition, okay, and we have to apply where we have stress A minus by stress B is equal to 100 times 10 to the power 3 psi, and it's because stress A or stress B is not equal to 0. Okay, so from here we're going to do stress A. Okay, we're going to do stress A minus by stress B. So this will be good. So stress A. So to get stress A, we just take this whole thing, copy, paste. We have this whole term. Okay, and then we just minus. Okay, so the first time stress A, I'm going to have a plus down here, and then the next one I'm going to have a minus. Okay, so this is the minus square bracket over here. I'm going to paste this term over here, right? And now over here, the second term over here now, this will be a minus square bracket. Okay, and then from here this will be, so we know that these two can be, so minus minus plus, these two terms can be cancelled off. Minus minus plus, so this is plus twice. Okay, and then I'll just I think I'll just paste again. No, I'm going to copy this term over here. Okay. In fact, this is a new line. Do apologize for this. So this will be equal to 2 twice, and this whole term will be equal to 100 times 10 to the power 3. Okay. Alright, I'm going to come back again for the last part of tutorial 11. Thank you.